Good morning, everyone. I welcome you all to this next lecture of Dynamics of Machine. And in today's lecture, we'll be going to discuss about the governor. We'll continue the discussion on the governor. So in previous class, we already discussed what is a governor and what are its functions, how it is going to work. That also we saw in very brief, but this is we are going to discuss in great detail while we do the we'll study each and every governor individually, right? Then we also saw how it works, and we discussed some of the examples, practical examples for uh, how the governor works regarding the uh, power which is supplied to our households, right? Then how in vehicle the governor, who is the governor and how it is working, and so on. Okay. Then we also saw comparison between flywheel and governor. That flywheel, and we learned that the flywheel works for the cyclic fluctuation. Okay, the cycle on which the machine is running. So the fluctuations produced during the cycle, they are done by uh, governor. Okay, sorry, those are controlled by flywheel. And governor is responsible for external variations, controlling the engine speed during external variations. Okay. Then okay. Then we have to start with the classification of governors. So governors are basically classified into two types: inertia governor and centrifugal governors. Inertia governors and centrifugal governors. Now these centrifugal governors are further classified into two types, three types, I would say. One is spring-loaded governor, second one is dead weight governor, and third one is pendulum type governor. So in this pendulum type, we have only one, which is Watt governor. In spring-loaded, we have four types: Hartnell governor, Hartung governor, Wilson Hartnell governor, and Pickering governor. And in dead weight loaded, we have Porter governor and Crowell governor. Okay, so these are the types of governor which we have to study. Basically, we have to study centrifugal governor itself. And in our syllabus, in RGPV syllabus, Watt governor, Porter governor, Crowell governor are predominantly asked in your end semester exams. Some questions might also come from the properties of the governor. Okay, these four governors are rarely asked, although we are going to study all of them because it is in the syllabus of your higher degree exams, higher order exams such as GATE and engineering services and PSU exams and so on. Okay. All right. So let's get started. Before going to each and every governor, let's first understand this. So centrifugal governors. In the centrifugal type governors, the change in centrifugal force of rotating masses due to the change in engine speed is used for movement of the governor. So as the name suggests, that it works due to centrifugal forces. Okay, centrifugal forces of the rotating masses. As we saw in the diagram of the first slide, that these are the balls and they rotate about this spindle. Okay, about the axis of the spindle. So since they will be rotating, they would be having some centrifugal force, and by the help of that centrifugal force of the rotating masses, we are able to uh, govern the movement of the sleeve. All right, which is controlled by the dead weight of the sleeve. Also, dead weight of the sleeve is also used, or spring might also be employed. Okay. Thus, the principle of operation of this type of governor is based on change in mean speed. Okay, so when the mean speed is changed, the it comes into operation. Then it comes into the operation. That is the centrifugal governors. So mainly the centrifugal force, the dead weight of the sleeve or the spring may be employed in these centrifugal type governors. Okay. Inertia and flywheel governors. The second type, which is inertia governors. So in these governors, the principle of operation is different from the principle of operation of the centrifugal governors. They are somewhat different from the centrifugal governors. Okay. In these inertia type of governors, the inertia force used by the angular acceleration of the engine shaft or the flywheel is used. Okay. So whenever there is some angular acceleration in the engine shaft, okay, we already studied about the acceleration of engine mechanism, right? So whenever there is acceleration or change in speed, this inertia type governors sense that, and on that principle, they change the mean speed which are utilized for movement of the balls or the masses. Okay. Thus, the movement of the balls is decided by the rate of change of speed. So how much the balls will raise and increase the radius of the governor, it is decided by the movement of the balls. Okay. And it is governed by the rate of change of speed. Here the change in speed is used, but in flywheel or inertia type governors, the rate of change of speed and change in speed both are used. Okay. What is rate of change of speed? It is nothing but acceleration. Thus, governors of this type are more sensitive than the centrifugal type, since there are two governing things uh, which will uh, which will change the speed. That is, which will govern the uh, fuel supply. That is, change in speed and rate of change of speed. Okay, so therefore it is more sensitive as compared to the centrifugal governors. But simplicity of centrifugal governors makes them more popular. They are easy to construct and assemble, so they are more popular as terms of usage. All right. Moving forward, inertia governors. These governors work on the rate of change of speed as well as change of speed. Okay, so there are two factors which are working in case of inertia governors, and hence these are more sensitive but less stable. Okay, so in the further classes you will study about the stability of the governor, and we will see how to determine the stability. So there we will be able to numerically see that inertia governors are less stable. Okay. In centrifugal governors, these are less sensitive, okay, as compared to inertia governor, but more stable. So centrifugal governors are more stable and robust in construction. All right. The working of these governors is based on change in speed. So only change in speed is the factor in over here. And in inertia governor, two things, that is rate of change of speed and change of speed. And we know that rate of change of speed is acceleration. Okay. So it works on two things. Okay. Also, these governors are more popular due to practically no maintenance cost. So one, its construction is robust, that is its manufacturing and assembling is uh, easy compared to the inertia governors, and also there is very minimal maintenance and running cost uh, in case of centrifugal governors. Therefore, these are more popular. Okay. All right. Moving forward. Now, we'll see some terms related to the governor. So as you can see this diagram, let me uh, show. So this is the spindle and this spindle, as you can see, it is connected to the gears. Okay, so these are called the bevel gear, which are connected to each other at 90 degree, right? So engine shaft might be connected over here, all right, and this another shaft is the spindle on which these things are mounted. Now these uh, these are called the upper arms or the arms of the governor. Okay, in the arms, these fly balls are mounted, or we'll call them as just balls. So these balls are attached to the upper arms of the governor. Okay, uh, these two are called the lower arms or the links. Okay, uh, one end of these links are connected to the upper arm, and the other end is connected to the sleeve. So this entire thing is sleeve. Okay, this entire thing is sleeve, and this sleeve is connected to the lever, and that lever is connected to the throttle valve, and this throttle valve controls the supply of the fuel or the working fluid. Okay, so as the sleeve moves up or moves down, according to it, this throttle valve will change its position. Okay, so its position might sometime come like this. So more fuel, there will be more space for the working fluid to go to the engine. Okay, and sometimes its position might come like this. So it will, that is, it is restricting the fuel supply. Okay, all right. I have drawn it by hand also, so it might be more better understanding over here. So we have generator over here. All right, this generator's shaft is coupled with the shaft of engine. Okay, and in to run this engine, the fuel is supplied from here. All right, now this is the crankshaft. This is the gear arrangement, bevel gears, and this is the spindle. Okay, this thick shaft which you see in the between, this is the spindle. All right, over the spindle, the sleeve is mounted. The sleeve is mounted. The sleeve is connected to the lever which controls the throttle valve. Okay, now the sleeve is also connected to the lower arms. The lower arms are connected to the upper arms or maybe balls for ease of drawing, and the upper arms, the lower arms are also directly connected to the ball. Over here, you will see that the lower arms or the links are connected to the upper arm and not directly to the ball. Okay, but for ease of drawing, we can, while drawing the line diagram, we can draw like this also. Okay, and these are the upper upper arms. So if you watch this closely, no, what you will find is that this is link number 1, this spindle. This upper arm is link number 2. This lower arm is link number 3, and this is link number 4. This sleeve is link number 4, and this sleeve slides up and down over the shaft. Okay, this slides up and down over the shaft. All right, so it is a kind of slider. So if you watch it closely, these are 4 links, and one of the link is a slider. Okay, there is one fixed link, other 3 are moving links. So it is very similar to slider crank mechanism, and this is link number 1, okay, which is fixed, link number 2, then there is link number 3, and link number 3 is connected to the slider. Okay, and it slides over link number 1. So this arrangement is very similar. This is link number. This link number 1 is fixed. It rotates about its own axis. Link number 2, this has degree of freedom of moving about this hinge. Okay, so during construction, this upper arm is hinged to the spindle. Okay, so it can go like this also, it can go like this also. Similarly, this lower arm is hinged to the sleeve. Okay, all right. So this is a kind of slider crank mechanism. Okay, so it would be easier for you to visualize and understand how this works. Now, we have governor axis or the spindle. So this is the axis around which everything rotates. We have upper and lower arms. So these are the upper arms and these are the lower arms. There is sleeve, there are balls. This is sleeve which is mounted over the shaft or spindle, and these are balls also called as fly balls. Then there is governor radius. Now what is governor radius? As you can see over here, that the distance of the center of flywheel to the spindle axis is called the radius of the governor. Okay, this is called the radius of governor. Again, the distance from central axis of the spindle to the fly balls is called the radius. Okay, then there is governor height. So what is the height of governor? Height of the governor is this plane of the balls, the plane of the balls in which the balls are rotating, the distance between that plane to the this hinged point. Okay, the hinge point where upper arm is mounted to the spindle. So this is the height of the governor. Okay, then there is governor equilibrium speed. We'll see the definition in further slides. And there is lift of governor. So understand this: when the speed of the engine increases, that is, if the load decreases, if the load of the engine decreases, what happens? The speed will increase. The speed will increase. Okay, if the speed is increasing, that means these balls will under the action of centrifugal force will try to move out. Okay, they will start rotating at higher speeds. So if they start rotating at higher speeds, this will lift up. Okay, this arrangement will become something like this, and sleeve will also move up. Okay, this sleeve will also move up. So arrangement would be looking something like this. All right. So initially the height was this. Okay, now the plane of the ball has lifted up, and now the height of the governor is this, that is h2. So as you can see, as the speed increases, this height reduces. And if you watch closely, if you have been listening me closely, you will realize that the radius of governor has increased. Okay, the radius of the governor will increase. So as the speed increases, the radius increases, radius of the governor increases, but the height of the governor reduces. Okay, and similarly in third position, let me draw it by different color. In third position, if the speed of the engine is reduced, okay, if the load is increased, all of a sudden, if the load is increased, then the speed of the engine will reduce. If the speed reduces, this balls will rotate at lower speed. Okay, so its next configuration would be something like this. This balls will rotate at lower speed, and it will push the spindle at some lower position. Okay, so it will now look something like this. So here you will see this is the plane of rotation of the balls. Its height has, the value of height has increased, but the radius of the governor decreased. Okay, so if the speed increases, what will happen? The radius will increase, the lift will increase. Okay, if it is lifting more, then height of the governor will reduce. Okay, again, if speed of the engine increases, the radius of the governor will increase, the lift, there will be more lift, the spindle will lift upward, hence the height will reduce. Well, opposite to this, if the speed decreases, if the speed of the engine decreases, the radius of the governor would decrease, right? Lift of the sleeve will reduce and height of the governor will increase. Okay. So I hope you understood this, that what is the working and what are the important terms. Also, governor radius is shown over here, that R2, the value of R2 is less and corresponding height is more, and the value of R1 is more, that the value of radius is more, the corresponding height is less. Okay, so at at lower speeds, the radius is lower and the height is higher. At higher speeds, the radius is higher and the height is lower. All right. Governor radius, its definition is given over here. It is measured in the plane of the ball rotation. Okay, so this is the plane of the ball rotation. The horizontal plane in which both the balls lie. Okay, that is the plane of ball rotation. So the governor radius is denoted by small r. It is measured in the plane of the ball rotation, and it is the distance of center of gravity of the ball, CG of the ball, from the governor axis, right? So we saw this in the previous slide itself. All right, moving forward. Here are some of the definitions. What is the height of the governor? So the height of the governor, the vertical distance from the center of the ball mass to the point of intersection of the arm, okay, or arm produced on the axis of the spindle, is called the height of the governor. So wherever the upper arm is attached to the spindle, from there we will start measuring till the plane of rotation of balls, or the vertical distance between the CG of the ball and the top hinge of the upper arm. Second is equilibrium speed. Now, what is equilibrium speed? The speed at which the force on the balls, arms, and the sleeves are in complete equilibrium. So, when a particular speed is achieved, at that point, the resultant force on the system is zero. That is, the force acting on the balls, the force acting on the arms, and the force acting on the sleeve are cancelling each other out. Okay, in that case, the system will be at equilibrium. There will be no unbalanced force, and there is no movement of the sleeve up or down. The sleeve is rotating at its own pace. It is not moving up or down, and that speed is called as the equilibrium speed. Okay, next is radius of rotation. Radius of rotation we already saw, the horizontal distance from the axis of the rotation to the center of the mass, ball mass at any speed is called the radius of rotation. So distance from the centroidal axis to the CG of the balls. Okay. Then there is mean equilibrium speed. The speed at the mean position of the ball mass is called the mean equilibrium speed. So this is mean equilibrium speed. Now maximum equilibrium speed, the speed at which the maximum radius of rotation is called the maximum equilibrium speed. So there are three types, that is maximum speed, minimum speed, and the mean speed. Okay, so it is depending upon the radius of rotation of the balls. If the balls are at its maximum radius, then it means it is the maximum equilibrium speed. The ball, if they are at minimum radius, then it is minimum equilibrium speed, and so on for the mean equilibrium speed. Sleeve lift. Sleeve lift is the vertical distance traveled by the sleeve due to change in equilibrium speed is the lift of sleeve. Okay, so it is the vertical distance traveled by the sleeve. Okay, this sleeve moves up and down. The sleeve moves either up or down depending upon the speed of the engine. Okay, if the speed of the engine increases, these balls will uh, go further outward and upward, so it will result in lifting of the sleeve. Okay, and vice versa when the speed decreases. So that is called as sleeve lift. The sleeve will move upward. It is called as sleeve lift. The vertical distance traveled by the sleeve due to change in equilibrium speed is the lift of the sleeve. Okay. Now let's see the operation of the governor. Or this is where we conclude our class today. Thank you, everyone.